In last lecture, we read about permittivity, relative permittivity, and we solved a numerical. And now we are going to read about the superposition principle of electric forces. Okay? Superposition of electric forces. Here, if there are two charges placed in at a place, and there is another charge Q naught placed near these two charges, then this charge exerts electric force. If this one Q1 is positive and Q naught is also positive, then this charge repel this charge, this Q naught charge, along the line joining the two charges. So this is the force of first charge on the second, means this Q naught. Similarly, this charge also repels the charge Q naught along the line joining Q2 and Q naught, and this is the F20 or 2 naught, we can say, and its direction is this much, and this is the direction, okay, of this force. Then how much the net force, what is the net force acting on Q naught? Certainly, if we are asked to find the net force on the charge Q naught, then we add these two forces, and that is added vectorially, means by using vector rules, because forces are vector quantities. Okay? The superposition principle of electric force states that the resultant or net force acting on a charge placed close to a number of charges is equal to the vector sum of all the electric forces exerted by individual charges. That is F equals to F1, F2, F3, where F1, F2 and F3 are the forces due to the individual charges. Here, if we are going to find out the force here, it is a vector plus F10. This. Okay? Let us see a numerical related to the superposition principle. Okay? Two charges, one into 10 to the power minus 6 coulomb and minus 4 into 10 to the power minus 6 coulomb are separated by a distance of 2 meters. Determine the position of null point. What is null point? Null point is that point where the net force is 0. Okay? We know that the net force on a charge can be 0 if there are two equal forces acting opposite to each other. And that's why if this is charge Q1 equals to 1 into 10 to the power minus 6 and this is another Q2 equals to minus 4 into 10 to the power minus 6 coulomb, we have to place another charge. We have to place another charge in such a way that the force exerted by this charge on the test charge, okay, or the third charge, and the force exerted by this charge on the third charge or the test charge must be equal and opposite. So if these two charges are placed at 2 meters, here it is already given, we have to place the third charge in the same line in such a way that the forces on the charge, on the third charge will be equal and opposite. Okay. So if you place a plus q naught charge here, the third charge is the q naught charge, plus q naught, then the q1 charge will repel it by F1, this is the F1 force, and this q2 charge will attract the test charge q naught towards it, and that is F2. They are opposite to each other. Their value must be the same. Only then they can cancel each other, and the q naught will be then at the null point. So suppose this is the distance x from the q1 charge where the null point lies. Let x be the distance from the charge q1 is equal to 1 into 10 to the power minus 6 coulomb, at which the null point let q naught be the test charge, which experiences net force, zero resultant force. Okay, experiences zero resultant force or experiences zero resultant force. And in magnitude we are going to find out the F1, then F1 equals to, in magnitude we are going to find out F1 equals to 1 by 4 pi permittivity naught q1 into q naught upon x square away from q1. F2 equals to 1 by 4 pi permittivity naught q2 into q naught upon x plus 2 to the whole square towards q2. Okay. But net force on q1, sorry, q naught is equal to is 0. Therefore F1 must be equal to F2, or q1 into q or 1 by 4 pi permittivity naught q1 q naught upon x square equals to 1 by 4 pi permittivity naught q2 q naught upon x plus 2 to the whole square. Okay, or q1 upon x square equals to q2 upon x plus 2 to the whole square. Only we have to put the value. Okay, only we have to put the value of the two charges, not the sign. Okay, q1 equals to what? q1 equals to 1 into 10 to the power minus 6 upon x square equals to 4 into 10 to the power minus 6 upon x plus 2 to the whole square. Okay, on solving we get x equals to, on solving we get x equals to 2 meter. Okay, and in the next lecture we will study some more numerical related to electric force. Okay, thank you.